Alright folks, we are back for Chapter 1, Lesson 2, Understand Proportional Relationships. For this one, students will use models and ratio reasoning to understand how a proportional relationship can exist between quantities. I believe we got some vocab words for this one, just one. One vocab word you're going to need to take and write down, proportional relationship. Not letting me highlight it today, but that's okay. You can see it there. Make sure you get that vocab term written down. And now we are going to start on the lesson. When mixing blue paint and yellow paint to make green paint, the amount of blue paint and yellow paint you use can create a lot of different variations in the green. You could use 1 part blue and 1 part yellow, or 3 part blues and 1 part yellow. Including white paint in the mix gives you an even greater variety. Suppose you mix 4 parts of blue paint and 4 parts of yellow paint. Is this the same shade of green as missing 4 parts of blue paint and 2 parts of yellow paint? I don't think so, because there's going to be a lot more blue in that setup in the first one. These are the kind of questions we're going to learn how to answer as we continue on in today's lesson. When baking, the ratios of ingredients is important to maintain. The table shows a common recipe for pizza dough. Too much or too little of any ingredient will not create good dough. In this recipe, the ratio of cups of flour to the cups of water is 3:1. Suppose you wanted to make 2 batches of dough. Is the ratio of flour to water going to be the same? What if you wanted to make 3 batches? Is the ratio still going to be the same? These are the questions inquiring minds want to know. The bar diagram shows the relationship between flour and water for the different batches of dough. In each batch, 3 equal sized sections represent the cups of flour, and 1 section represents the cups of water. If you did 1 batch, you would have 3 cups of flour to 1 cup of water. 2 batches, you would have to double everything in there. 3 batches, you would have to triple everything, so that now you can see you'd have 9 cups of flour to 3 cups of water down here. These are examples of proportional relationships. Whether you do 1 batch, 2 batches, or 3 batches, you have to have the same exact ratio between the ingredients. The ratio of cups of flour, the ratio of cups of flour to 2 cups of water is maintained regardless of how many batches of dough you make. In each batch, there are 3 cups of flour for every 1 cup of water. 2 quantities are in a proportional relationship if the 2 quantities vary and they have a constant ratio between them. For example, the recipe calls for 2 cups of flour for every 1 cup of sugar. The ingredients are in a proportional relationship because while the number of cups of flour and sugar can vary, the ratio of the cups of flour to sugar is constant. Some relationships are not proportional relationships. In these cases, a ratio is not maintained. For example, suppose Pedro is 14 years old and his little brother is 7 years old. The ratio between their current ages is 14:7. Pedro is currently twice as old as his brother. But will he always be twice as old? Well, if we were to double each of those years, or add 7 to each of those years, now Pedro is 21 and his brother is 14. Is 14 half of 21? I don't think so. Move through the steps to see once again how the bar diagram can be used to solve this type of problem. Because Pedro is twice as old as his brother, the bar diagram representing Pedro's age as twice as many sections as a bar diagram representing his brother's age. So you've got 14 years to 7 years. Next, if we were to add 5 years to each of them, now they've got 19 years to 12 years. Is that the same 2:1 ratio? It is not. It is not the same 2:1 ratio. Therefore, it is not going to be a proportional relationship. And you can see right here they have that cool not equal symbol right there. The not equal symbol is something that you may or may not be familiar with. It's just an equal sign with a slash through it. Will there ever be an age other than 14 and 7 where Pedro's age is twice as old as his brother's age? What do you think? Write down your answer. The answer is no. The older they get, the less the gap is going to be between them. There will always be a 7-year gap, but the less the size of the ratio between them will be. The recipe for homemade glass cleaner indicates to use a ratio of 1 part vinegar to 4 parts water. Elise used 3 tablespoons of vinegar to 12 tablespoons of water to make the cleaner. Is the relationship between the vinegar and the water in the recipe and the vinegar and the water in Elise's cleaning solution proportional? And it wants us to explain our answer. Think about it. What is the relationship between the parts of water and the parts of vinegar? Let's take a look. To determine if the relationship is proportional, Elise must maintain the same ratio of vinegar to water. Move through the steps to see how a bar diagram can be used to determine if the relationship is proportional. For every 4 parts vinegar, there's 1 part of water. The units represent the part do not matter. The units could be cups, gallons, quarts, tablespoons. It's all the same. A part is any unit that you could want it to be. Elise used 3 tablespoons of vinegar, which is going to be 1 part, and 12 tablespoons of water, which is going to be the 4 parts, because 12 is divisible by 4 3 times. 1, 2, 3. So you can see here you've got your three parts each. You could argue three parts of vinegar to 12 parts of water, and that simplifies down to be 1 part vinegar to 4 parts water. The ratio between the vinegar and the water was indeed maintained when Elise used the ratio. Would this ratio be maintained if you used 1 cup of vinegar and 4 cups of water? Explain your answer. Pause the recording and do that. For the next part of this problem, we're doing with the same 1:4 ratio, but now it's getting a little more complicated. Autumn uses 2.25 ounces of vinegar and 9 ounces of water. Is the relationship for vinegar to water going to be the same as the recipe for the cleaning solution? Is it going to be a proportional relationship? Pause the recording, answer the question, collect your done, and then you can look at some sample answers. For me, the easiest way to find out the answer to that is going to be to find out is 9 4 times 2.25. So I'm going to get my marker going here, 2.25. Let's make that pin a little bit smaller. Multiply it, I said make it smaller, by 4. And when I do, 4 times 5 is going to be 20. 4 times 2 is 8, plus a 2 from the 20 is 10. 4 times 2 is is 8, plus a 1 from the 10 is going to become 9. Bounce, 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 bounce. So that is equal to 9, which is the same number of ounces. So now I have to take and type that in. And what I typed is that I multiplied 2.25 by 4 and found that it was equal to 9. This means it is still a 1:4 relationship, so it is proportional. What did they say for their answer? Well, let's click done and show my sample. And their answer said, yes, Autumn maintained a 1 part vinegar to 4 parts water ratio. Well, theirs is not as cool as mine. I think I did a better job on that one. Moving forward. Now this is where we're going to stop part 1. We'll come back to part 2 here in just a minute. Don't want to make the videos too long, and we will continue going over this topic of understanding proportional relationships.